combinations. Combination of n objects taken r at a time is the same setup as for the permutations, except for this time with the combinations, there's no regard to order. So the example of the horse race, well, it matters whether a horse comes in first, second, or third place. It matters if a runner does. It matters on a lot of things like that. But sometimes it doesn't. If 3 people are going to get tickets to, you're just going to have like a lottery, that would be no regard to order. Just 3 people are going to get tickets. Or a committee. An easy way to remember combinations is like a committee where the order doesn't matter. And permutations is like electing a president where order does matter. Can I back up one screen? Okay. So, okay, you're welcome. Okay, I'll just wait here for a half a second and take a little sip of my water. Okay. So the formula for combinations is a little different when order doesn't matter, because along with n factorial over n minus r factorial, you also divide by the r factorial by itself. So we're going to have, whoops, too much, let me, hang on just a second. I'm going to make all this stuff appear. I wonder if I can make all this stuff appear at the same time. I don't think I can. Never mind. I was going to try and make this look better. To work these out with the combinations, we got 16 factorial over 16 minus 4, which is 12 factorial times 4 factorial. Well, the 16 factorial is 16 times 15 times 14 times 13 times 12 times 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. The 12 factorial is 12 times 10 times 9, and so on down to 1. And then the 4 factorial is 4, 3, 2, 1. Always in a bigger number factorial, there's always a smaller factorial contained at the end of it. So because the 12 is less than the 16, we can cancel out that whole 12 and the 12 factorial out of both of them. So see how we canceled out the 12 factorial in the red here, leaving 16, 15, 14, 13, and then 4, 3, 2, 1. Well, the 16, 15, 14, 13, and the 4, 3, 2, 1 also cancel. 4 goes into 4 one time, and it goes into 16 4 times. 3 goes into 3 one time, and into 15 5 times. 2 goes into 14 7 times, and then the 1, of course. So I really only have to multiply, and I did it up here, the 4 times the 5 times the 7 times the 13. And that comes out to 1,820. Okay? So you can write this all out and just cancel. The majority of combinations and permutations are just canceling. Or you can use Excel. Excel syntax is C-O-M-B-I-N, combin, and the number, comma, the number chosen. So it's n, comma, r. The larger number always goes first, then the smaller number. So 5C3 would be the number of combinations of 5 objects taken 3 at a time. Combin 5, comma 3 would be 10. The calculator, the TI-83 gives, go to the math menu, go left to the probability submenu, go to 3 to select NCR, you can just drop down to 3. Go back to the main screen, enter the smaller number, and press enter.